Hi, my name is Anna Yanakopoulos, and I'm an undergraduate student participating in the 2016 DISC REU at Notre Dame. This summer, I've been working on monitoring a program called Lobster. Picture this. You're a scientist and you have a lot of data. Too much data for you to analyze, too much data for your laptop to analyze. You need hundreds or even thousands of computers all running your specialized analysis software. Usually, this means you need to buy a bunch of computers, set them up, test them to make sure everything's working, hire people to make sure they stay that way. That gets pretty expensive. But what if you didn't have to do that? What if you could just use someone else's computers? There are over 25,000 computer cores available through Notre Dame's high-performance computing cluster. Can we use them to do data analysis like that? This is where Lobster comes in. Lobster is a program that manages computational jobs and the computers that run them. Lobster ensures that each compute task has access to the resources, programs, and files it needs to run, no matter where each of these things is located. Naturally, this is a pretty complicated job, and a lot of things can go wrong. Lobster keeps track of everything it does, all of its successes and failures, in a monitoring system that looks like this. These plots show everything you need to know in order to figure out what's happening if something goes wrong. Right? Well, these plots are static. They're just images. You can't add new plots or change the ones already here without directly modifying Lobster's source code. What if some component of Lobster fails in a way that no one ever expected it to fail, and there are no plots that answer the questions that you're asking? Enter the ELK open source software stack. ELK stands for Elasticsearch, Logstash, and Kibana. Elasticsearch is a database and a search engine for log files. Logstash collects log files and sends them to Elasticsearch. Kibana is a graphical user interface for making plots and visualizations from logs stored in Elasticsearch. This summer, I created an interface between Lobster and the ELK stack. This interface sends all of the log data that Lobster produces to Elasticsearch. It creates a ton of useful and interactive visualizations in Kibana. You can move these visualizations around, change their sizes, their colors, add new visualizations. They update automatically to include new log data as Lobster generates it. You can zoom in on interesting time ranges. Maybe there were a lot of failures over a particular time period, and you want to know why. You can filter these visualizations. Maybe you only want to see failed tasks. Maybe there's a specific computer that for some reason wasn't handling your tasks very well. Maybe you want to see the full logs of the tasks from that computer, and what error codes they returned with to try to debug whatever's going wrong there. You can do all of this and more using ELK monitoring. On the other hand, using the old Lobster monitoring system, you can stare at this page and hope that something shows up on one of the plots before you have to start searching through all the log files, manually. As you can see, the ELK stack adds powerful tools to Lobster's monitoring that make the debugging and troubleshooting process much quicker and more efficient. The more quickly we can figure out what went wrong, the more quickly we can solve that problem and get back to doing science.